Now we're going to look at multiplying complex numbers and our algebraic laws that work for this as well, and some tricks which help. So now that we know that I is the square root of -1, if you think about powers of I, and this will come in handy, this is on your notes as well, then I squared is root -1 times root -1. The roots just cancel to give you -1. So I squared is simply -1. And if you keep going and you multiply by I again, so I cubed, then you're multiplying -1 by I. So you'll just get -1I, just minus I, and I to the 4, you're multiplying by I again, so you'll get minus I squared, and I squared is -1, so you'll get -1 or +1. So I to the 4 is 1. If you think, you can also think of it as I squared times I squared, which is -1 times -1, which is +1. Okay, if you then times by I, you'll get 1 times I, you just get I again. Okay, so we can think of the top one as just I, can't we? Just so it's all kind of in order. And then I to the 6 is I times I, so I squared again. So what happens is we're going to recycle this pattern. So we're going to have I -1 minus I 1. And this goes all the way down. So if you keep multiplying by I, this continues. So every fourth power of I, it starts again. So we have I squared is -1, I cubed is minus I to the 4 is 1, and it starts again. I to the 5 is I to the 6 -1, etc., etc. So we get this pattern. And if you just think about I to the 7, we can write this as I to the 4 times I cubed. I to the 4 is 1, and I cubed is I squared times I. So we get 1 times -1 times I, so just minus I. Okay, there it is. So this cycle is really useful, and it helps you to cut to quite big powers of I quite quickly and quite easily. Okay, once you become comfortable using it. And as you'll see later on, we get some bigger powers of I, and we can work them out very, very quickly, although they look like they'd be quite ridiculous to work out. But anyway, let's have a little look at some of our questions. So still carrying on. So this will be question 8 in your exercises. Oh wait, hold on, we're back to number 1 for this section. So we've got 2 plus 3i and 4 plus 5i. So when we multiply these together, we can expand these just like we expand normal brackets. So 2 times 4, 8, 2 times 5i is 10i, 3i times 4 is 12i, and 3i times 5i, so 3 5s are 15, so this is 15, I times I is I squared. And what you'll get comfortable doing, quicker doing, is recognizing you can simplify these to make 22i, but I squared is -1. So this is 15 times -1, so just -15. And then we can combine the real parts to make -7, and we're left with the 22i. So here, you want to get good at multiplying I by another I. So this is 15i squared, 15 times -1. You should be able to go straight to -15 after some practice. But don't be afraid to write in the powers of I at least to start with, until you're comfortable doing that. Okay, so that was one part A, wasn't it? So 1A, 1B is 7 minus 4i squared. And exactly the same rules can be used. We can write this as 2 brackets times together, or we can shortcut. So square the first term, square the 7, 49, times these two things together. 7 times -4i is -28i, and double it, -56i, and then square the last term, so we're squaring -4i. Okay, and these can be a little bit funny because we've got minus signs, then we've got I squared, which changes the sign again, so you just got to be very careful, as always with the signs. -4 squared is +16, I times I is I squared, so this is 16i squared, and if you're getting better at it, you'll have noticed already, hopefully, that that's going to turn out as -16. So you can get 49 -56i -16, and then subtract to give you 33 -56i. Okay, so you want to get really comfortable at powers of I and timesing these out. You should be comfortable with all the algebra, but it's now also translating this algebra back into a value, because we know that I actually represents root -1, and therefore I squared is -1. Let's have a look at question 2. So 3 parts, so simplify I cubed. So we've talked about this already on the left hand side here. So we can see this I cubed is minus I up here. But I cubed, probably a good way of thinking about this is I squared times I, which is minus 1, times I, which is just minus I. Part B, I to the 4, again we've got this on the left. Here's I to the 4 is 1. And we talked about this before. Good way of thinking about this, I squared times I squared. Minus 1 times minus 1, positive 1. And part C, we've got 2I to the power of 5. So remember, when we raise it to a power like this, both bits get raised, so you get 2 to the power of 5, which is 32, and I to the power of 5. And again, we've got this written on the left hand side, I to the 5 equals I here. If you haven't got that written out next to it, you won't have. Sorry, my laptop died. I don't know what's happened. Right, so it looks like you're going to have to listen to me going downstairs to get my charger and coming back. So sorry about that brief interlude. Hopefully we're back on track now. So we get 32I to the 5, so 2 to the power of 5 is 32. I to the power of 5 stays as I to the 5. So we'll have 32, and then if you use I to the 4 and any multiple of 4, they're always going to be 1. Okay, here it is, I to the 4 is 1, I to the 8 is 1, etc, etc. So this is I to the 4 times I, that's how you want to think about it. You won't want to write this in the exam once you get used to it. Hopefully you'll just be comfortable going in 32 times 1 times I, so just 32I. Then we go on to question 3. So question 3 says, given that A plus 3I multiplied by 1 plus BI is equal to 25 minus 39I. Find 2 possible pairs of values for A and B. Okay, so it sounds like we're going to get quite a few answers here. So the only thing we can really do here is, if we look at the left hand side, is that we can multiply this out using our new skills we have learned. So A times 1 is A times BI is just A, B, I. 3I times 1, 3I, and 3I times BI will be 3BI squared. If you're getting better with this, you can go straight to minus 3b, because the I squared is minus 1. And let's just put our, so let's write that. So I squared is minus 1, so this is minus 3b. And then we're going to put our real bits together, so the bits without the imaginary parts, so A minus 3b. And then the bits with the imaginary parts plus 3i. And then we can also, if we want to be extra clever, which obviously we want to be, we can take out the I. So we've got our real bit here and our imaginary bit here. Okay, so then we can have a little look at the full question. So therefore we can say that this part, A minus 3b plus AB plus 3 times I, must be equal to the right hand side, because that's what we're told at the start. So we get this. Now at this stage we have got something quite similar to having surds and rational parts matching and irrational parts matching. We have the same with complex numbers. So if 2 complex numbers are equal, then that means their real parts must be the same, and also their imaginary parts must be the same. So the non-I bits, they're equal to each other, and also the imaginary bits, the I bits, the coefficients of I, they're equal to each other as well. And hopefully we can now see we've got 2 equations here, simultaneous equations with 2 different variables, so we can solve these simultaneously. So if I rearrange this, by adding 3b to both sides. Call this equation 1. Call this equation 2. Then I can sub equation 1 into equation 2 and replace a with that. So I can have a is 3b plus 25. So ab will be 3b plus 25 times b plus 3 is minus 39, and we can solve this. So expand. We've got a quadratic here, which is fine because it says we're going to get two sets of solutions or different solutions. One side 0, so we can add 39 to both sides, which gives us this. We can use our calculator so we can check the discriminant. It looks like a bit of an awkward one to factorise. If it does factorise, we could check that. But I think we're going to get both pluses, aren't we? I think we're going to get 6, 7, so we get 3b squared. 18 plus 7 is, yep, so that looks good. So we're going to get this. So b is minus 6, or b is minus 7 over 3. So two different values of b, and then we can sub back in. So we can sub into 1. So when b, let's take minus 6 first because it's an integer, a will be 3 lots of b plus 25. So here we're using this equation now to find a with each value of b. So a will be minus 18 plus 25, which is 7. So either a is 7 and b is minus 6. There's one solution. Or we've got when b is minus 7 over 3. So a is 3 lots of b. Again, using that original equation up here, this one. This isn't too bad because we've got 3 times minus 7 over 3, so the 3's will cancel. So we get this, 25 minus 7, so 18. So our second set of solutions, that a is 18, when b is minus 7 over 3. And there's our different sets for a and b.